So continuing with our transformation of logarithmic functions discussion here, let's suppose again we still have the original function f of x equals log base 2 of x, right? And we did various transformations to it, right? So let's say we first vertically stretched it by a factor of 4, then we shifted it left 3 units, and then we shifted it up 1 unit. What would be its equation in terms of both f and x? And then we sketch this below. So again, remember what these basic transformations did to the function, right? So a vertical stretch by a factor of 4 would be taking f of x and multiplying it by 4. So that would be 4 times f of x. A shift left 3 units would actually be taking f of x and replacing x with x plus 3, because remember the form is x minus h, and in this case h is negative 3, right? Because it goes left 3. So when h is negative 3, x minus negative 3 becomes x plus 3. So it's f of x plus 3. And then if we shift it up 1 unit, that would be another outside transformation. So it would be f of x and then just add 1 to it. So we're basically putting these three things all together. And when we write this function in terms of f now, putting 1, 2, and 3 together, we end up with 4f of x plus 3 plus 1. So that's what it is in terms of f. And then how would we write that? Well, what is 4f of x plus 3 plus 1? That's going to just be a 4 on the outside. And now log base 2. But instead of having x, we have x plus 3. And then we have a plus 1 on the outside. So there it is. So that's your equation in terms of f and x. Okay? And now we want to sketch it. So remember what we can do with this is think in terms of the transformations. Again, this is one way to do it. You could just plug in various points, but if we think in terms of transformations, right, we have the point 0, I'm sorry, not 0, 1, 1, 0. We have the point 1, 0. I keep getting the exponential and logarithmic confused. 1, 0, 2, 1, and maybe we want to do a half negative 1. So what we're going to do is we're going to take these points through each of the transformations, right? So when we do a vertical stretch by a factor of 4, this basically multiplies y by 4. So 0 times 4 is still going to be 0. So this point stays 1, 0. 1 times 4 becomes 4, so this becomes 2, 4. And negative 1 times 4 becomes negative 4. So that was the first transformation, vertical stretch by a factor of 4, which basically made 4 times y, right? So the next transformation is going to be shifting left 3 units. So that's going to be doing x minus 3. So we're going to take away 3 from the x. So 1, 0 becomes negative 2, 0. 2, 4 becomes negative 1, 4. And 1 half negative 4 becomes subtracting 3, right? So that's negative 2 and a half, negative 4. And then the third transformation, which is shifting up 1, that's easy, right? That just makes y plus 1. So now our final points, right, are going to be negative 2 comma 0 plus 1 becomes 1. Negative 1 and then 4 plus 1 becomes 5. And then negative 2.5. Negative 4 plus 1 is negative 3. So we're going to now use these points as our points to plot, right, on our graph. And the other thing to note is, since this thing was shifted left 3 units, what that did is that moved the vertical asymptote to x equals negative 3. So that's something you want to keep in mind, right? The vertical asymptote was shifted to negative 3. So now if we go to graph this, let's see what we got. Let's just draw a little basic grid here. x, y. We know we have a vertical asymptote at x equals -3, which is going to be over here. So that's a good guideline to have, right? And we have a couple of points here, -2, 1, which is going to be here, -1, 5, which is going to be up here, and -2.5, -3, which is going to be down here. So you can see it still has the same basic shape as the normal logarithmic graph, except mainly the things that happened here are it got shifted left 3 and it got vertically stretched. So that's why it's steeper than the normal logarithmic graph, right? The normal logarithmic graph is actually pretty flat, right? This one is actually quite steeper because it was a vertical stretch by a factor of 4. So now when we connect this, again, I mean, you're just doing the best you can here. This is going to go like this, and this is going to connect here and here. And it is going to level off. I mean, it's still going to go to infinity, but it's going to go to infinity slowly. Oops. Fix that. There. So that's basically what it looks like. I mean, we have the 3 points. I mean, you could get more points. Like if you wanted to, you could try to find what the y-intercept is even, because there's a y-intercept on this graph. But the y-intercept might not come out to a nice point anyway. It might be a fractional point, an irrational number. So those 3 points are enough. So if you have 3 points and the asymptote, that generally gives you enough info to draw a decent sketch of the graph. You can still see, right, it's much steeper than the original graph because of the vertical stretch by a factor of 4, and it was a shift to the left. So you can see that there's actually going to be a vertical asymptote there at -3. Yeah, you can see here the y-intercept wasn't a nice value anyway. It was some irrational number, right? Because 7.34 is not an exact value. It's just a rounded irrational value. So does that look like our graph? Yeah, I'd say pretty good, right? Looks good. Yep, there it was for a second. But you get the idea, right? All right, so that's basically your shifting, your transforming of logarithmic functions.